Section 4.3, Logarithmic Functions, Part 1. Logarithmic functions and exponential functions are inverses of one another. What were the properties of inverses that we learned a few chapters ago? One property was that a function and its inverse will reflect on the line y is equal to 1. If this were a piece of paper and I were to fold right on the y equals x line, this graph would match with this one. This graph would match with this one if I look at folding. Notice the x-axis as the horizontal asymptote of the exponential function becomes the vertical asymptote of the logarithmic function. Logarithmic and exponential functions are inverses of one another. Here's what the exponential graph looked like and its properties. That's what we learned in the last section. Domain negative to positive infinity, unless there is a transformation, range 0 to infinity, horizontal asymptote the x-axis. Here's the inverse of the exponential, which is the log. Domain 0 to infinity, range negative to positive infinity, vertical asymptote is the y-axis. Okay, so the function and its inverse reflect along that line y is equal to x. We also learned if f of x is equal to xy, then f inverse of x has the coordinates y, x. An xy coordinate of f of x is the yx coordinate of f inverse of x. Notice that the domain becomes the range, and the range becomes the domain. The domain becomes the range becomes the domain. We're flipping the x and the y. Okay, so summary of this slide, there is a lot. Logarithmic function and exponential functions are inverses of one another. They reflect along this line, y is equal to x. I could fold, and this graph would fold and match up with this graph. If I know an xy coordinate of the function, it's the yx coordinate of the inverse. The domain becomes the range becomes the domain. And we can look at asymptotes, horizontal for the exponential, vertical for the inverse. Okay, here's what a logarithmic function looks like. We have log base a. Exponential was base a raised to the exponent. Here we have log base a of x. Our notation for logarithmic functions. For example, we could have log base 8 of x. We could have log base 10 of x. We could have log base 3 of x. We could have log base e of x. Those are all example logarithmic functions. Some functions are used so often, like base 10, that it has its own notation and its own name. Log base 10, notice we dropped the 10. It's just used so much. We drop the 10 and it gets its own notation, just log x. Anytime you don't see that number there, it's understood to be 10. Log base e is used so often, it gets its own notation. That's ln, or the natural log. In our calculator, log and ln are here right next to the 7 and the 4. Inside of the math menu is here. Inside of the math menu, it's nice if your calculator has this log base button. You don't have to have it, but if you don't have it, it's okay. But if you do have it, it's a nice feature to look into what it can do for you. Okay, so we're on to part 2 in the next segment.